We're gonna start. See the problem 4. Numbers of which and points and types of questions. Either targets a zero index of 2D arrays types as a count. There are the count questions as a type. Each one has words and mark points. Okay, so numbers of way you can earn exactly your target points in the exam. Alright, so types. What is the types? The questions is indistinguishable. There are 3 questions of the same type, assuming the first 2 and the series that is sending. Then solving is same as solving 1 3. Okay, I know. So first we can get the target is 6. So idea is that we can flatten them to 6, and also we can get this 4 questions and 1 type, so we can flatten them to. Okay, go find the number of way to reach a target. Target is not big, so we can get a DP of this. So idea is that we can flatten the types. Is the DP vectors. Very slow. Okay, so let's return DP target. Numbers of way. DPI is the numbers of way each target. So idea is that the number is very small. We can just do that like this. So for example, okay, so over count and points in the types. You know that count is 0 and the point score we can get is v1. Right, so actually we can just like for let's say the first score we can get is dp0 is 1, zero score we can get is 1, and then for I is equal to target score to 0, greater than the score. Score and want the value. We can do count time. Yeah, that's sorry. Exactly target points and is large. The first idea is that we can get this. So we can do count time to do this. So we can do 6 time. We have the 6. Sorry, we have 6, not a 6 time of this. So we get is dp1 is equal to okay, so dp2 can get its Wait, what is that here? Numbers of greater and target. Yeah, so what is the idea of this? Something wrong, right? DP, given the types, we know dpi is equal to dpi minus score given from this and types of this. I get the numbers of way, but the five and what kind of idea? That there are what uh okay, so it's not kind of simple problem. Let's do another problem. So pass the pillow. Okay, do problem one. So there are people standing on the line. First person is holding the pillow initially. Every second, the person holding passes the next person standing on the line. Reach the end, this will change. What it means that, for example, once the pillow reaches the next person, it passed to minus one person, and so on, holding a pillow after a second. So there are four people, and the first one is holding the pillow, and every second we will pass. So we either pass to minus one. Oh, sorry, okay. So it's like this: 1, 2, 3, 4, 3, 2. It's a cycle. This okay. So of course, find the numbers of time. You can just simulate it. 1, 2, 3, 4. 3, 2. Alright, just simulate it. Find the index that holding pillow. Simulate it. Simulate it. What we can get is 1, 2. 1, 2, 3. You get 3, 2. So erase that. And we're starting from the minus 1. Starting from the yeah, that's the idea. No, that's the idea. So once so problem 1. Also the problem 2 is that case largest sum in the binary tree, given a root and level sum is a sum valued at the same level, the k largest level sum 7. What I get is 2. If there are fewer than the k levels in the tree, then -1. So we just get this heap. We can use heap to do this. Yeah, and also we can get is that DFS. Find the k's largest label. Largest label. So yeah, idea is that we use BFS to calculate each label. Yeah, the labels, and push the root. We still have a queue to do this. for each label. Get a sum and get this current and we'll get its sum about current value. Push to the left, right. The node is always be 2. Okay. So current left, Q push left. Current right is and labels push back the sum. His largest value, so it's 2. We'll get its we have sort. We sort by the largest, sort by decreasing, sort by descending. Yeah, and if level size is greater than k, is written yeah, okay, that's this idea. Alright, problem 2 and problem 3 is that spare array to the prime product. You are given the numbers and the speed is that the co-valid. Means that the speed is co-valid. The product first I plus 1 element and product remaining element are co-prime. So that means that index 0 is valid because 2 and 9 it's co-prime against split. 1 is not co-prime because they are from the first element is 1 person's and so on elements, and the 3 is that the co-prime of this. So this okay, I mean no idea. So let's find the GCDs 1. Okay, course that find the first and the last GCDs. First, last GCDs 1 per dot elements GCDs 1. What is idea? Yeah, I know. Actually, it's very simple to do this, so we can just try to find a common divisor of this. Actually, we can just try to we can find the smallest index. That means that we're doing from left to right and just calculate if they have common GCD. GCD is the mean value of this, so all mean values should be 1, should be 0 here. So just use a map to do this. So it's a prime factor. And the prime, actually, I don't know the idea, so the time complexity, naive time complexity is going to be prime per dot the prime numbers and per dot the length of this, because each time we need to compare the prime of this to get a minimum. Yep, and so let's get we get a prime of this. Each value So if we know the prime, each value is equal to x. We can use this to get each values twice. We don't need to use y factors to do this. So yeah, so let's say given the prime, get the prime. It's workable. I think it's workable. Given x, and after that we will and we need times p to get check GCD. Yeah, and yeah, that's the idea. Yeah, we use the count. Prime count. Just check this if this is common. Right, so for pre-calculated table, for each values in the numbers and pre-pushback, we get prime factors of this, get primes and get a count of this. Yeah, so it's a pair. I think it's a pair. Yeah, so what is the idea? I think, alright, it's fine, I think. Prime table. We update it. Oh, wait, I don't want to make a function, just try to do that. Let's do we got prime. And get its prime count of the p will add count. Yeah, and also if the px is not equal to 1, prime count of the x will add 1, because this is prime, also prime. Yeah, it's prime count of this. So let's say it's a suffix. Right, let's get the suffix and prefix. I'll get a prefix. Yeah, and also let's say answers is not -1. So we found an index of this. We will return it as a 2 because 2 can get us 1. So for says we are calculating the map of this the prefix, the prime count minus the count of this, and prefix x minus 1, prime count x minus. Yeah, and what is the idea? You know, we need to compare if the prime table is the same. If they don't have the what is the idea? We got a suffix, and now they need to check if trace is equal to suffix. Yeah. Alter the prefix. If prime count p is also greater than 1, yeah, that's idea. Compile p times p is smaller than x. Smaller than O. Alright, it's too lazy to find. Wait. Saying that 0 will get its prefix, will add some. Why is fail? Oh, it's not. Sorry, I doing wrong. 2 to 3. 2 to 3. Why is 2 to 3? You're not valid. Scale minus p. Suffix or minus. X is not equal to p. The count is 0. What is first is greater than 0? Not greater than 1 is greater than 0, so still be here. So 5, that means it's negative 1. Not answers. Answers is negative 1. If okay. 2, 3, 4. Oh, we cannot get +1. We cannot get to the last index. I know that, so with 0, 1, 2, 3, 4, cannot get to the last index. Alright. Okay, that's it. Well, time limit. I'm not sure the time complexity because I think it's quite big. Alright. Yeah, so check the GCD. Yeah, I think this is the correct way to do this problem. Should the time complexity, but yeah, it's good. Alright, let's see the problem 4. Problem 4 is kind of DP problems, See, actually, it's very simple to do this. We can get scores that value 1, can get this 1. So, numbers of way we can get is that for each times we can get is 0, we can get this 1 way. And we get a 2. 2 we can get a 1 will again 1 have the 2 ways, but it's not. So I think that can get this 5, get this 3, get this 25. So 2500 is equal to 2500. What is it? I think it's not hard, but I need some time to figure out what is something wrong in this problem. This problem may be easier than the problem 3, because this is a classic problem. But you need to think that how do we deal with the same type, because the same type is not a same, another yeah, we get from the DP of the from DP, so we either moving to the next, can either use them or not use them. So we can set this DP. So starting from 0, and if our target we get is we can use times this. I want to use top-down DP to solve this problem. I say this kind can be used top-down DP to solve this. It's quite simple. So we're starting from get current can get starting from current index. So if current is greater than the target, no matter what happens, return 1 is equal to target. No matter what happens, 1 is current is equal to target. Yeah, so no matter what happens here, if I is greater than it means this fail. And we have the resource. Yeah, and it's DP. So so answers is we're starting from 0, and the current value scores can get 0 for the count in the types I. Types I, the first we can do count times of this. So we can get this resource is add about resource and I plus 1. Target times the types I1 times J plus 1. So score. yeah, it's memo. Okay, it's kind of DPI currents. Okay, so it's DP vectors. Yeah, that's the idea. It's top down memo. This high complexity is straight ties. Alright, so wait, what? Points. You get 6, y is fail. You can get this one is you can get 1, 2, 3, 4, 5, 6, right? So you can get starting from 0, you get 1, then skip to next. You get a 6. Alright, so current type I1. Current. Not sure. What is wrong? Why is wrong? Or we can either skip. Services cell can either skip to next type. Sorry, I forgot. Skip type I or use I. Sorry, I forgot to skip. We have 2 operation. Yeah, that's the idea. Alright, so it's problem 4. Yeah, I do a little slow, but yeah, it's not that hard. It's kind of the classic DP. I know we can optimize to linear space, but I'm so lazy to figure out that. Yep, so that's it here. We either skip len or we either use a type I, and user type I will get this. Okay, it's kind of DP. What's this part? Oh, BFS. Alright, so to see this problem, well, it's more or less than problem 4. I think you can just swap the space. Swap string for makes sense. Yeah. Alright, so to sometimes service just be wrong. 6 be wrong. Alright, maybe this place. Okay, good. I don't have any penalty of this at all 4 problems. It's kind of good. Alright, so let's see the problem. Yeah. What is fast? Yeah, what is the problem of problem 1 that goes to the 4 problem? Yeah, it's kind of like I know can use another way to sub this, but then to still be to figure out the DP transition. But let's see the first problem. The pass the pillow. Let's just the problem is saying that we have n people standing in line we have 4 person for C example 1, we get a 4 person in the line, and each time we get to the next position, we get the next person. So 1, 2, 3, 4, and go back. So we want to know what is the pillow after time seconds here. Actually, you can get this mass, but still be approach is that we can use linear time to sum this. Yeah, we can use linear time to sum this. Let's still be, we just use the array to do that. We push back the array 1, 2, 3, 4, 5. Just do as the problem said. We just do this and cycle. We can get the position. Yeah, so 0 times first person. Yeah. Alright, that's the problem 1. The problem 2 is find the label case logic sum in the binary tree. And what is a case logic sum? Is that label sum? We want to find the case logic label sum in the tree. And in this example, let's get the first label is 5, the second label is 17, and this is 13, this is 10. And want to get a largest, want to get two's largest label sum. So is first largest label sum, and this is a second. I gotta return this. Actually, we just BFS sorting len and return the answer. So this is problem 2. And about the problem 3, it's a math problem. You want to find out that the first prefix and the last suffix, the GCDs equal to 1. And we cannot use the product. We cannot really product len because we will product len, the value is very large. So we can use prime factor to represent each number, each product. To do this, we just compare the prime factors. Now the problem is how to prime factors. You can use just square for each value. Try to see if this is more than 0, and if more 0, we can add it, calculate into the hash table. And if it's not 1, it means that the prime, this self value is the prime, because after prime fraction, after this calculation, the x should be 1. Alright, so we just do first time to calculate the or prime factor count. After that, we calculate the prefix and the suffix. We check if prefix is equal to suffix. So we do this again to calculate prefix, and we also minus the count as a suffix. So we can get the first half and second half. Now we can just compare about the prime of any one. We can compare the first because the first is smaller. We just compare the first. You can guess check that if the second half has a common prime divisor, because C is increasing. If we have C, that means that C is always be 1. So if another person is to be 1, that means that, okay, this is fail. Return false. Right, so, and I can use another table to do this. I can use a table to do this, say count suffix. Actually, you can use is the we can use this. We can use this to fast the suffix search. Yeah, so to fast the search. Sync. This is more faster. We don't need to use a hash table. Reduce the time to very quick. Yes, yeah. 2 seconds to 0.8 seconds. 300 milliseconds. It's quite important because hash table constant is large. Okay. So so let's idea. We can use hash table, but again. But so okay, let's idea. Let's idea. The time complexity is this. Add this. So or 7 is nearly pass. Right, so it's good. So about the problem 4, it's DP. You want to find numbers of way to endpoints. We have some types, and we want to make what is the numbers of way you can use these marks to get the target points. And know that the question on the same type is indistinguishable. That means that problem of same type, they must use the same. They cannot have the order. They must they don't have the order. And also but I think the different type I think it's not the way is not the same, because if we can use 2 and 3 to get 5, we also can use 3 and 2 to get 5. I think the way is equal. So I don't know why this is not why this is not a sensing. I don't know, but yes, and you can use top-down to do this. The time complexity, the top-down DFS is that either we can skip or we can use the type. And use the type, we can get this kind of target. The time complexity is the target times the I and times the transition. It's quite small, so it can pass the constraint. Alright, so but a follow-up question is that, can you do this as a less space to linear space? To do this, I think it's yes. But how to do this? You know that basically you want to think about transition of the DP. So DPI is numbers of way to reach target, right? And and what? And also need to find the get 1 and get 2 and get 3 and get 4. So if we are doing this 6, we'll get us 1. 5 will get us 1. 4 gets 1. I have no idea. I can use the top-down approach to do this. I have idea. Can use top-down. Actually, just numbers of ways equal to 1 is a base case. I have idea. We can use score, for score. So Yeah, sync each type. We can get this. The first is the count. The second is the score. Is equal to v1. And we can get this total count score. This is the can do j times put 1, we put 1, put the 2, and we put the 3, put the 4, put the 5. Scourge and score. Score mode, and each time after calculated, the DP score be 1. Yeah, I think this is idea. Alright, so this is not an idea. And still be to think about what is the top-down approach. Yeah, and to still be, but I think we can use top-down to get the bottom up. Let's see this case. If we're starting from 0 and then get is that a type of this, also we can get is we can either skip to type information. Alright, so use top down to solve this. DP 0 and SDP. Yes, DP is DP. DP is SDP. Yeah, so I think we can do as from do each time the count score. I'm so stupid. Score at BP. Right. This is SDP. Yes, let's see. Sync SDP. Target. Yeah, I think this is good. This is top-down approach. Alright, it's the top-down approach. Yeah, it's actually we can just use the score. It's okay. We don't need to really use them. It's okay. It's fine. Yeah. So the next DP came from the current DP at, so we can get the space to optimal. Yes, so yes, yes, good. The runtime, yeah, it's very small. Right. Okay, I think it's not a hard problem. But actually, you need to careful this duplicate. You need to care for duplicate. If you use the DP, it's hard to do. So just use a rolling DP. This is rolling DP, so you can use bottom up. But I think top down is more simple. Yep, is easy to sublet and easy to figure out that. Yeah. Alright, that's the today's contest. Still took some time. Alright. This guy's very fast. Okay, so yeah, second place by one. Seriously. Very slow. Yeah, but yeah, I don't know. Right? Yes.